three-dimensional function is the most common, also the most difficult because of all the different pieces. So this one is a version of question 3. And it definitely has, I can't kind of call it real symmetry, but it has asymmetry of sorts. Would you agree there's a kind of pattern here? And typically, if there's some kind of nice kind of relationship, you would expect some kind of reasonably nice answer. I'm keeping my fingers crossed that that's actually what's going to happen here. In other words, when we come to do the Curly specially, that we get an answer checking what it is. It's kind of nice. Let's do the divergence. If you want to do that, guy, you just have to remember this is P, this is Q, this is R. And the divergence then is first one with X plus the second one with Y plus the third one with Z. And although that looks quite bad, it's not actually as bad as it seems. So let me just do it at the side here. I want to differentiate the square root of X over 5 plus Z. I'm going to rewrite it a little bit differently. It's essentially that. This here is really just a constant. It's like a half or a fifth. And that's going to be called that. So when I differentiate it, I'm going to multiply by the power, reduce the power by 1. And then I'm going to put those guys together and bring this one downstairs and then make it look like the original. I'm looking at the answer. I don't know why they wrote it that way, but who cares? This guy is 1 over 2, 5 plus Z, the square root of X. I could certainly do that one the same way that I did this, but with respect to Y. I could do that one the same as this with respect to Z. But I should be able to predict, and I've got a cheat because I can see it, but I would have probably predicted the same thing, what these two answers are. So let's have a look at what the original turns into and try and see if there's anything that may follow in the next one, right? So you notice that square of X is now on the bottom. So I would make a prediction that that goes there. There's a 1 in the top, so I'll make that prediction is still a 1. On the bottom, I've got 2 lots of 5 plus Z. I would certainly say there's going to be 2 lots of, but what do you think instead of 5 plus Z would go here?
Plus X.
Yep. And this one would be 1. Anybody want to have a shot at the last one, just based on patterns?
It's the same as the other ones, but this time it's 5 plus Z times the square root of X.
Are you sure about square root of X? X got you
No,
X,
sorry, Z.
Y got you Y. Yeah, okay. And what about this thing in the brackets? 5 plus X, 5 plus Y, 5 plus Z, based on what happened here and what happened here. Right. Now, it's a little bit dangerous to do patterns, but this time it worked. And it wasn't that hard to do, so you don't need to do patterns if you don't feel comfortable in it. And I would only look for patterns in functions that look like there's some type of weird symmetry going on. Well, the div is typically the easier of the two. And now we're going to do the horrible one, which is the curl of f. So we're going to do I, j, k. If you want to write it as a cross product, it's the grad operator with the vector function. So the grad is d by dx, d by dy, d by dz. And f ends up being this ugly guy, followed by this ugly guy, followed by this ugly guy. So we would do so many i's, take away so many j's, plus so many k's. Okay, now, if I just do I in this example, and I'll leave j and k to you because you're going to have to do these guys anyway. The major diagonal is differentiate with respect to x, this guy, right? So that's major diagonal. Take away the minor diagonal. Oh, we got lucky. What is the derivative of this fraction with respect to y? What's the derivative of this with respect to y? Big fat zero, yes, David. So this is the only guy that I really need to deal with. And so I'm just going to write him down. And I'm going to rewrite him like that. And now I can multiply by the power. And I can reduce the power by 1. And then I can make it look pretty. So this answer here is, let's check it. Good. No, not good.
Aren't you supposed to do dy, or sorry, ddy and the ddz for I?
I should have. That answer is correct, but that answer is correct for the answer that goes here. Okay. So this one that I just did is the one that belongs here. Okay. I basically did that guy take away that, which is the k guy. Okay, that's good. That is the correct answer, but it's the correct answer for the k component. Actually, if I rewrite this guy a little bit clearer, do you know the other two, because I can see them? The other two answers look just like that with changes. So you might be able to guess what the other two are just by using symmetry. Nothing special in 4. Let's do a piece of 5. Our vector function in 5, they are calling it arctan. I refuse to call it arctan. It's inverse tan. Inverse tan. And inverse tan. So it has a kind of symmetry that you might be able to guess the other two answers for. Let's just do the curl. And again, I'll only do one piece of the curl, and this time I'll try and do the right piece. It's going to be I, J, K. The operator for the grad. And then the vector field. And so many i's, take away so many j's, plus so many k's. And I'm only going to do the i's, so cover up those guys. So our answer is going to be the derivative with respect to y of the inverse tan of zx. Take away the derivative with respect to z of the inverse tan of yz. Okay, let's take each one in turn. I'm going to take this guy first. Oh, I should have thought about that. Don't you get that guy times y? Because treat it just like a constant. Right? It doesn't have any y's in it, so if you want to differentiate it, 0 is the right answer. Now, if you differentiate the second one with z, which is the inverse tan of yz, that is a real question. Okay, anyone remember what the derivative of the inverse tan function is? Derivative of inverse tan.
1 over x squared plus 1.
Okay, and think of x squared as a placeholder, right? So it's 1 over yz squared. But technically, isn't this a chain rule? And the inside function is yz. So when you differentiate yz with respect to z, don't you get an extra y? And so the answer is y over 1 plus y squared z squared. Are you comfortable with that? And so we got 0, take away that guy, which means the first part of our answer is negative y over 1 plus y squared z squared. We are right, which is good. Let's go for it. This guy has a pattern. This is the answer for the x position, right? Let's see if we can predict. And I've got the advantage if I can see this one. But let's do the predictor on what this middle one is. X gets you this. What do you think y would get you? Well, I'll start with the first one. Negative. Any takers?
It's going to be symmetric to the top, except it's x instead of y.
Okay. And what's the bottom going to be then?
1 plus x squared z squared.
Yep. What's the last one going to be?
Last one's going to be also negative z, but instead of negative z x squared plus z squared. No, sorry. Yeah.
That what you said? You want to change that last one? Are you happy with that last one?
It's going to be x squared y squared.
Yep.
I have a question.
Yes, David.
Because the J is negative, would that mean that would be positive, or does things bounce out?
That's a very good question. I myself, if I didn't see the answer, would have probably thought that that might get cancelled out and become a plus. But evidently it is a negative for all three of them. So somehow or other, the symmetry took care of it. Interesting. But yeah, good question. I would have probably thought that's a negative and therefore the middle one would be plus. But the answer is they're all negative. I'm not saying this is an alternate to doing it from scratch. I'm just saying, look, if it's got symmetry, you might want to have a fighting shot at trying it. If it works, then haven't you saved 10 minutes? And if it doesn't work well, you just do them the slow way and you'll get the answer. If there is no symmetry, no detectable symmetry, then do not do it, right? Do not try and make a pattern when there's no pattern to be made, obviously. Right. The next question is a change. We are given a rather convoluted function of x, y, and z, basically various polynomial combinations. And we have to first determine if F is a conservative field. If it is, what will be the answer to the curl of F? If it is a conservative field, what will you get?
0.
You will get 0 as in a scalar or 0 as in the 0 vector. Let's be pernickety here. Curl of F, 0 vector or just the number 0?
0 vector.
Correct. Aren't curls always vectors, right? So if you're going to get 0, you're going to get a 0 vector. So that's the first jump. And can I tell you that we did it and it was 0, right? So we don't need to. That's something for you to fill in. The second part is we are now going to find a guy that we've done before. We're going to find the potential function. Little f of x, y, z. And we all know why we want that potential function, because if we have that potential function, can't we use it to get the value of a line integral? Because won't we just need to know where it started and where it finished and we'd be done? Now, the potential function has the property that the curl of f is equal to capital F. And the curl of f is the partial derivative of x, y, and z. And it's going to equal this guy, this guy, and finally, that guy. And I think I'm going to do it in a separate piece of paper. Let's start by using this one. To remind you, what you do is you integrate with respect to x. All the other variables are considered constant. So basically, it's a power rule. I'm going to add 1 to the power and divide by the new power. Are you comfortable with the integral of this is that? And then you're going to finish with some function that doesn't have an x in it. So I'll call it g of yz. And that's just a placeholder to make things work. And so I'll put a big circle around it so I can remember. Then I'll move on to the second one. And the second one has to equal 9x squared, y squared, z squared. And I'll integrate it with respect to y. So that's this guy, and I'm going to do the power rule and divide by the new power. And I'm going to get that. And my arbitrary constant is going to be some function that doesn't have a y in it. And there's my second version of the potential function f. And then the last one is 6x squared y cubed z. And I'm going to integrate it with respect to z. So these are just numbers. Add 1 to the power and divide by the new power. And I get this guy, plus some arbitrary constant, which will be a function that doesn't have z in it. And then to finish with, to get the potential function, there it's full title. Don't you just combine these three together? In fact, this combination is going to be one of the easiest combinations out there, because don't they all just have the same answer? What would, it didn't happen here, but let's just pretend that there was a y squared here and a y squared here, and let's say a z, I can't get a z for this one, and x squared plus y squared here, just for argument's sake, right? So that one, right, had an extra plus y squared in it. This one had an extra y squared in it. This one had an extra x squared plus y squared. Wouldn't you just combine them together and get that? Now, do you notice y squared, and y squared doesn't get you 3y squared. It just means you've got a y squared. And you know that little orphan x squared just means you get an x squared. So you may sometimes have to add on little bits because one or more of these has an extra term. And the placeholders basically take care of that. Technically, I shouldn't have got a y squared there, so I'll make that x. Are we good? Right. And they don't even ask you to do a line integral. They stop at finding the potential function. Here is our vector function. The natural log of 5y, an x over y, whoops, an x over y plus a natural log of z, that's ugly, and then a y over z. So 1, that's my p, I guess that's my q, right? That's my r. And we have to find out if it's conservative or not. And if it is, which this one happens to be, and you're just going to trust me because I know the answer is 0, that it's a conservative field. That'd be part A. Now we're going to find the potential function. So here goes. F of x, f of y, f of z is going to be the natural log of 5y, x over y plus the natural log of z, and y over z. Ooh, that's going to be fun. So the first one is that guy. Right. Matching this first for the first. Chloe. She's a low nuisance. Right. Integrate the natural log of 5y with respect to x. What's the answer? What do you get if you integrate this with respect to x?
X natural log of 5y plus g of yz z.
Yep. Thank you for correcting it to z, Mia. Every little bit helps. Okay, there's our first one. So don't we know that the potential function is at least going to have an x log 5y in it, right? It might well have other stuff, but it's definitely got that. It may have only that, of course, as well. Okay, if you integrate x over y plus the natural log of z with respect to y, things get a bit messy. X over y gets you x natural log of y. Are you comfortable with that? It's 1 over y gets you a log y when you integrate it. And yep, we've seen a log before, but this time it's going to get you y log z plus a function that doesn't have any y's in it. So h of xz. And there is our second look at what f could be. Let me check I haven't written anything. No, I kind of was worried why that's not the same, but we'll come to that in a minute. And the last matchup is probably the least onerous one. If you integrate this guy, you'll get y log z plus some function that doesn't have an x or a y in it. Interesting. I definitely think that I've got that guy. Okay. And if I got this guy, oh, that's not what I was expecting. And then I've got this guy. Is that a y? Log z. Oh, that makes more sense. I like this guy. It's really nice when two things have something. So I'm going to call that one good. And this is my issue. That's our answer. And I'm not convinced it should be the answer. That's why I'm worried. So I'm double checking that I just didn't write. Oh. No, I'm still unhappy with that answer. This is the answer. That's the answer I think we should have got. Now, I can tweak my answer a little bit. Would you agree that the natural log of 5y is the natural log of 5 plus the natural log of y? Would you agree with that? Which, if I multiply it out, it is x natural log of 5 plus x natural log of y. So if I write this guy up here as x natural log of 5 plus x natural log of y, doesn't it just match this guy here? So when I combine them, we now have an x natural log of 5, that's him. We've got a couple of places where x natural log of y, and we've got a couple of places where y natural log of z is. And I'm now looking at their working and finding out why they don't have that term. Right, let's show you their solution, which does not look, well, it kind of looks like me. Do you see they've got the guy I had? And they got this guy, which there's a 6 set. Oh, well, that shouldn't matter. Okay, with or without a 6 set. Oh, it's probably when you go in and out they change the question. Okay. So either Z, but it's a 6 set. Nothing wrong with that. And so they have this guy. And then they have one to Y log Z. If you integrate this guy, oh, no, not taking that. No, you can't do that. That's not right. No, I don't accept that as an answer. So I'm sticking to my guns. You do need that X log 5. And if you had 6Z, you need an X log 6. I can't see where I went wrong. I normally make lots of mistakes, but not that kind of mistake.
Well, didn't you
So-
say it's the same? Like with the x log 6 plus the x log y, it's the same as the x log 6y? And they just have that one.
Oh, they went that way.
Yeah.
Oh, okay, we're good. Yeah. I broke it apart. They just stuck them together. Okay, I can live with that. Let's try another one with hopefully less controversy. So we're basically saying that these guys are similar to each other because all you're doing is adding in a constant. Okay, I can live with that. Question 8. Is it worth doing? No, too basic. Question 9. Nice and ugly. I'm just taking these answers off. They distract the heck out of me. Just close them. Shouldn't look at them. But a distraction. Right. Question 9 is going to be 5y z squared e to the xz, and then 5z e to the xz, and then 5xy z e to the xz. Okay. And we are going to do the curl of f. So y j. Okay. The operator for the grad. And p. Just change the color so they don't merge into each other. And so we're going to do that guy. So I'll cover up this guy. And so the term that's going to go inside the I is the derivative with respect to y of 5xyz e to the xz. Take away the derivative with respect to z of 5z e to the xz. Right. The only guy that is y is this guy. So everything else is a constant. So when you differentiate it, you get 5xz e to the xz. That wasn't too bad. There are two places with z's. So this is basically going to have to be a product rule. We're going to call the 5z the f and the e guy the g. I will be so glad when those people outside are finished all the other things that they have to do. Okay, looks like I have some painting that needs to be done. Right, differentiate this guy with respect to z, you get 5. Leave the other one alone. Plus, leave this guy alone. And then differentiate e to the xz with respect to z. And you will get e to the xz times the derivative of xz, which gets you an x. So you have 5xz e to the xz, take away 5e to the xz, take away 5xz e to the xz. They kill each other off, and you are left with that guy. I can tell you right now, this function is not going to be a conservative field. I do not need to find the j or the k component. So here's an obvious question, why? How can I tell just right now it can't possibly be a conservative field?
Because that is not 0.
Because that is not 0. That's how obvious the question was. So shouldn't I not waste my time? Shouldn't I just stop there and say not a conservative field? So your answer would be DNE, which is what you write down if it doesn't exist. If the first one is 0 and then j ends up being that, won't you stop? Right? The minute you hit something that's not 0, you know it's not going to be a conservative field. You don't need to spend another 5 minutes doing the other two terms. It isn't necessary, right? They're just not going to be a conservative field because all three have to be 0, right? It has to be the 0 vector.
So even if they like even if you had a 5e to the xz and then like a minus 5e to the xz, that wouldn't count because like they're like separate vectors.
They're separate components of the vector, yeah. So they don't.
Okay, that makes sense.
So it had to be 0, and if that was 0, wouldn't I move on to the j? And that had to be 0, and then I'd move on to the k, and that would have to be 0. And only if all three were 0 would it be a conservative field. And could I then go on and get a potential function? And the answer is yes, I could. I think I'd probably end up quitting teaching if I tried to do a conservative field on something that wasn't, because I would expect that the math would be horrendously ugly. Plus it wouldn't work after doing all that hard work, right? So, last one for today. Here is my vector function. And let's find its curl. Gut feeling, before we do it, Do you think this is going to be conservative or not? Any takers? Do you think it's going to be a conservative field or not? I'm
I
not
think-
getting many. Say again?
I think it will be.
Okay. I don't know. My gut feeling is that it certainly has a lot of symmetry in it. And when functions have symmetry, they very often are conservative fields. But I've seen some really ugly looking vector fields that are still conservative, right? So it doesn't need to be symmetric for that to be true. And I'm sure there are functions that are very symmetric looking that are also not conservative fields, right? But my gut feeling is I would think it probably will be. And I'm now about to find out if I'm right or wrong, because it's really just a gut feeling. I can't say there's an easy way to look at that, because at least for my brain, there's not. Right, you cross these guys out. And here it goes. If you differentiate this with respect to y, you get 0. Take away this guy with respect to z, and you get a cosine times a y. Okay, end of story. Would you agree that's not 0? Not a conservative field? Interesting. Well, let's show you what's left. We've essentially finished that section. So on this homework, there's all those little videos I like you to look at. Hit it there. There's one. And you're finished. Well, there's the solutions to an example one, a little video to go with it. And let's call it a day. Pretty good timing, a little bit early, but only a couple of minutes. So last name, and tomorrow we will get a head start on the next section, even though it won't be in the midterm, it won't be in the homework or in the online test. And just in case I forget tomorrow, Christian, what is special about this Monday coming?
It's Memorial Day.
And what do you think that means as far as us?
Holiday.
Yes, holiday. What you might not know is, and I definitely remember doing it, whether I remember to save it is another matter, that homework and online test get an extra day. So you've now got until midnight Monday to do both those things in case of something, you know, if you need a day to squeeze it in. Okay, so bye-bye. I'll hang about for any questions.
Did you ever figure out, sorry, my internet cut off, so I had to get my phone up. Why the answer for number 7 was like that, or?
Yeah, Matthew noticed something I didn't, that the log of 5x and the log of x are essentially the same. They're only differing by a number, and the number can be added into the arbitrary constant. So if you just called them both log of 5x, it works.